This is my micro applications final project, and I'm Jonathan Schultz. In front of the camera is an infrared lens. It basically provides accuracy to the thermopile thermistor circuit sensor in the back, which is on the other side of that circuit board. These four wires lead to a breadboard that is externally powered by 5 volts. You can see here's a thermistor circuit. Basically, the resistance will change as the temperature of the thermistor changes. That is fed by the white and the gray wire. The thermopile circuit basically is a bunch of serial connected thermocouples. So as it sees the radiant heat waves, this blue and gray wire produce a voltage differential. That voltage differential then goes into this differencing op amp that also seconds as a filter. So any excess noise gets filtered out, and then the signal gets amplified. The gain is approximately 1,000. Jumping across this blue wire, we go into another low-pass filter, which eliminates more low-end noise. That goes into a buffer, which makes sure that the signal isn't being changed past that low-pass filter. And then it goes into another differencing op amp to create the span of temperature that I want. Going to the microcontroller, you can see this blue wire, which is just going to ground, and then this brown wire going to pin 1.3 is the ADC. So that's where the microcontroller will pull sensing a voltage and pull the voltage off that pin at a certain allotted amount of time. The white and the black wire is the UART pins, which is being fed to the USB to serial converter, which then goes into my computer. In front of me is my Matlab files. So I have a live thermal plotter, which basically will cycle through and plot at a predetermined cycle rate or sample rate set in the thermal test portion. My serial on just basically initializes the COM port that I need to use, the send serial function, and then here's my main function. So if I hit run, you can see that on the lower end it's shifting about 5 to 10 bits, but as soon as I put my hand up in front of the sensor, it's getting like 350 bits or 250 bits of resolution off of the sensor. Inside of the microcontroller, there are a certain amount of samples being pulled in and then averaged at a different cycle rate, so that way when it comes into Matlab it comes out with a little less noise and it's a little smoother. And there was the end of the time running on that.